Hello, check. Hello, hello. respected dignitaries, today's chief guest, my dear participants, a very good morning to one and all. This is Dr. Venkatlalita Narla from ECE department. So welcome to you all for this day 5 Atal FDP on multi-carrier 6G communication for wireless communication, multi-carrier modulation techniques for 6G wireless communications. Today is very special day of this Atal FDP. Here today it will be there two important special things. First one is afternoon we have industry visit. We will visit to BSNL at Rajahmundry. One more thing is today's resource person was a lady. So by listening her profile also we will inspire. Okay. So welcome to dear Dr. V.V. Mani Madam. I request Dr. Vijayasri Madam introduce today's resource person to all participants.
A very good morning to all. Myself, Dr. Vijayasri Bolisetti, and I am Associate Professor in ECE Department, Aditya University. Now I take privilege to introduce our today's speaker, Dr. V.V. Mani Madam. She is a Professor of ECE Department in NIT Warangal. Dr. V.V. Mani Ma'am received her BE and ME degree in Electronics and Communication Engineering from College of Engineering, Andhra University, and PhD in Electrical Engineering from Indian Institute of Technology, Delhi. In the beginning of the career, she worked as a software engineer, Capricorn Global Solutions Private Limited, Hyderabad, and later she worked as assistant professor of Geetham University and full-time research associate at Indian Institute of Technology, Delhi. Later, she joined in NIT Warangal in April 2008 as an assistant professor in ECE department, where she has been a professor since March 2022. Her area of interest includes wireless communications, signal processing for communication, optical communication, and design of real-time test bed for 5G using SDR. She has more than 100 papers in credit in national and international publications and conferences. She supervised 10 PhD students, and currently 5 more students are working under her towards their dissertation. She completed 6 projects and 2 more are ongoing with the DST SERP, UKIERE, SPARC, India Asian with international collaboration. Dr. Mani and her research team developed a wireless communication laboratory for MTech advanced communication systems using SDR platform. She is a fellow member of Institute of Electronics and Telecommunication Engineers, IETE, India, and a senior member of IEEE. She visited many countries and presented her research papers. She spent 3 months at RICE University, Texas, USA, and a research exchange program. She held various administrative responsibilities at NIT Warangal and also served as student branch counselor for IEEE student branch NIT Warangal and won Dariel Chang Bronze Award for Best Student Activities. She also headed a computer center, NIT Warangal, in the year 2019 to 21 and served as Associate Dean, Staff Training and Recruitment for the year 23 to 25. She also published a book with CRC Press on visible light communication, a comprehensive theory and applications with MATLAB. This is a wide experienced profile of V.V. Mani ma'am, and we also feel proud to have that expertise person today with us to discuss on multi-carrier modulation techniques for 6G wireless communications. I welcome you, ma'am. Thank you. Now I request Dr. Mani madam to take over the session.
Okay, good morning everyone, to the participants. This is, Dr. R. Anil Kumar. I have completed my PhD. So indirectly one of the guide, our money madam. Actually, I was admitted in 2016, PhD admission. I started my research review in only one multi-carrier modulation technique, OFDM. At that time, there are a lot of papers. Actually, OFDM is started, research started in 1966 by, I don't know the other, 1966. In 2016, 2019, I was attended one FDP, like what you are going today, FDP. I was attended one FDP at NIT Warangal. Just the title is 5G wireless communications. So that is related to my research. That's why I attended. So Madam is one of the resource person there. Madam explained not only OFDM, there are many multi-carrier modulation techniques are there. So I connected that point. So I changed my research OFDM to extension techniques, other multi-carrier modulation techniques like GFDM, generalized frequency division multiplexing, OFMC, UFMC, and other NOMA, OTFS. There are many techniques I learned there. From 2019 to almost to 2021, I changed my research OFDM to and other multi-carrier modulation techniques. I learned lot of things from that point. I have published 2 standard essay papers and I got a PhD within 5 years from the J&K University. So only one FDP have changed my topic, my direction of literature review. That is because of our money madam only. I have continued the research in multi-carrier modulation techniques. So one of the reason I kept the title Multi-Carrier Modulation Techniques for 6G wireless communications. I kept one resource person name, first name, that is our Professor Venkat Mani Madam garu. First given acceptance as a resource person to come here and deliver the lecture, and also suggested one more person from Madam side. He came yesterday and explained very well. Madam, behalf of our participants, once again I'm honoring. Thank you so much, Madam, for your help. Okay. కేబుల్ ఓకే హాట్స్పాట్ కనెక్ట్
So again, thank you so much for inviting me for this FDP, Atal FDP. On behalf of Aditya Engineering College and Anil, who praised me a lot about my research area and my work style. So I was so impressed after listening to his words. So really I'm impressed today. Without giving my any inputs to the faculty members, I'm so impressed. After listening to my lecture, he could complete his PhD with 2 good publications. It's really a good motivation to any of the faculty member, right? So I'm a kind of a person who believes in hard work. So I grown up in a educational background family. My father was a teacher. My father-in-law was also a teacher. My grandfather is also a teacher. So we had a motivation from the family background. Everyone in our home should have a doctorate, either a doctor or a doctorate. That is the vision of my father, vision of my father. So, but unfortunately, he expired while giving his lecture in front of, before starting off Dasara vacation. So in the class, he was, because of the heart attack, he demised. And that took us a motivation to stand in front of the people. We should have a good vision. We should have a good background of education. With that motivation, in our family, we are the 3 members of my family. Myself first one and 2 brothers. So all 3 of us are having doctorates. One is an orthopedic doctor, the other 2 are doctorates. So we all 3 settled well. Attaining a very high standard degree from IIT myself, and my first brother is also JNTU product, and he's an architect, a well-known architect, and my second brother is Gandhi Medical College and Osmania Medical College, MBBS and PG with an orthopedic specialization. My sister-in-law is also a doctor, so she is specialized in gynecology from Andhra University. MBBS from Andhra University, and she acquired her PG in gynecology for 7 years in UK. So and she is a 22nd rank holder. My brother is a 256 rank holder. I am a 58 rank holder in MSET. So we are very proud. We are actually very proud, and we are also well motivated because of my father's words. So we promised to my mother so that we'll keep our father's design to the highest level of our degrees, attitude, right? Wherever maybe he may be. So always when I begin my lecture, I always pray to my parents and my grandparents. So please give us a good strength, good health, good habits, good attitude especially, and serve this nation and save the soil. This is the only agenda we have in our life. All 3 of us, whole of our family. So we stand in front of the members with our strong commitment, okay? So I graduated from Andhra University, and after that I was married, and then I moved to software, and again my husband transferred to other place. So in those days there is no other option from Hyderabad to move to Visakhapatnam. There is no software industry, and because of my children's, I quit my job without hesitation, without taking any other thought. Just, you can imagine what is the salary I was drawn those days. I just quit my job, I joined with my family. Then there is no other option other than taking a teaching job. So I joined with Geetham University as a faculty member with a BTech degree. Then I realized that MTech is important, very much important to continue in this profession. And also for me, the teaching is also another interest because of my family background. So knowingly or unknowingly, I don't know, maybe my father is looking from the above, right? So I joined for MTech program in Andhra University itself, and I graduated. Soon after I submitted my thesis, I got an offer from IIT Delhi for a full-time PhD work, and there were at that time 48 members were qualified in the written exam, and 48 members were called for interview. Out of 48, only 3 members were selected for in the domain of wireless communication. And after a semester, because in IIT Delhi system is different from other IITs, so in every semester we have to clear our subjects with a minimum CGPA of 7.5. So we have to complete within a 1 year coursework. We have to study again along with the BTech students, along with the MTech students. So we have to clear, we have to attain 7.5 CGPA in each subject, otherwise we have to withdraw from the course. We will be thrown out of the course. So out of 3, I only 1 remained in my group, being a lady, and because of my guide's research methodology and his roadway, pathway, whatever you can say, because of him, I am here today. So I could complete my PhD within 4.5 years. And before completion of PhD, I applied to NIT Warangal. I got an offer. So then my guide advised me, please submit your synopsis, then you join. Otherwise, you cannot write your thesis. So he also advised me, you join in the break of summer vacation so that you can get 2 months of time, you can complete your thesis. So as per his advice, I joined on April 15th in NIT Warangal, and session started in July 25th. So it was a very good time for me. I could complete my thesis and submit it, and started continuation of my journey at NIT Warangal. So after joining NIT Warangal, we faced a lot of struggles. It's not that easy to sustain in a government atmosphere. It is not like management control. It is like controlled by every woman, every man. So all of them are having equal power, because I'm a government employee, she's a government employee, he's a government employee. Nobody will throw you out, right? Nobody will throw you out even if you did a blunder also. So that is a system where, so no one, even a junior faculty member, never say good morning, good afternoon. We have to say good morning, good afternoon. So that is the situation we have faced. But anyway, we could stand up in front of the people, not an issue. And so successfully I became a professor, and as well as I completed so many projects. I completed 10 PhDs, 5 more are working towards the problem. And in India, we are the one who built a test bed, a software-defined based radio test bed for wireless communication demonstration. Our papers are also published. And so it's not, I'm not great that we are only one who have developed a test bed. IIT Delhi also developed a test bed. IIT Mumbai is also doing, IIT Hyderabad is also doing, IIT Madras is also doing. Out of all the test beds, ours is the cheapest one. So cheapest in the sense, we relied on software-defined radio platform, whereas they relied on Keysight technologies, and their software procurement, hardware procurement takes minimum of 10 crores worth, whereas our equipment takes only within 10 lakhs of worth. We could show the entire system of the work, how it is working. For any student, for any faculty, if they visit my lab, we will show you what is the wireless communication is happening in NIT Warangal. So I'm very happy. Today, all of my 10 PhD scholars who have received the degree from me or from my university, they are all well placed. They are also into NITs and IIITs. So I'm happy today. So is it connected, sir? Color mic would be better because I have to write in. ఇలా పెట్టాలి నేను అందరి సైడ్. ఓకే, డన్. రైట్, ఓకే. So again, welcome back to today's session. So as sir asked me to present a multi-carrier modulation techniques for wireless communication. So as the present trend is for 5G and beyond 6G, so the data rate is very much important. So how many bits you are sending per second is important. Like 4G, there are megabytes, and 5G is gigabytes. 6G is even targeting for terabytes of information. So you know the terabytes of information means megabytes, at least megabytes of information. So 10 to the power of 6 bits we have to transmit in 1 second, right? That is the data rate of a communication system. How many bits you are transmitting per second? So per second if you are transmitting 10 to the power of 6, same the per second if you are transmitting 10 to the power of 9, that is 1 Gbps. Per second if you are transmitting 10 to the power of 12, it is even more than the Gbps data rate, right? So 100 Gbps data rate is 10 to the power of 10 to the power of 10 bits per second. So to increase this data rate, the first of all, we should have a long bandwidth should be available in the spectrum. So whereas in the present trend, because as the number of users are growing up, they are allocating a large bandwidth for the each vendor, like your vendor is Airtel, Docomo, BSNL and each other persons of vendors. So they have to take auction from the TRAI, Telecom Regulatory Authority of India. So I want to buy this much of spectrum for my communication system. So as such, like Anil Ambani can buy even whole spectrum of the entire world, but it's not possible to give as per the regulations of TRAI, right? So each vendor is given only certain amount of data, certain amount of the spectrum which is available. So that spectrum, we'll call it as the bandwidth of the system. So I'll write, to speed up my lecture, I write short notes, like bandwidth means BW. So this bandwidth is how much bandwidth he has to buy. Suppose he bought 10 megahertz of bandwidth. So then how many signals he can accommodate in the given bandwidth of 10 megahertz. So if I draw a spectrum of 10 megahertz, this is my 10 megahertz bandwidth. So in this 10 megahertz bandwidth, we know the OFDM, orthogonal frequency division multiplexing, TDMA, time division multiple access system, and OFDMA, orthogonal frequency division multiple access system, right? So what is orthogonal frequency division multiple access system? That means the whole band is divided into sub-bands like this. In each band, he is allocating some certain number of data rate for each user. Suppose he is divided the whole band into 10 sub-bands. So in the 10 sub-bands, what we are doing, we are sending parallel data in each band. So in first band, we'll send some data, second band will send a data, third band also we send a data, right? So but this one, we are sending the data in parallel mechanism. At same time, we are using the 10 megahertz of bandwidth, and in each band, we are sending a data. So that means it is similar to your keeping whole of your items in one truck, or you divide into small trucks and load your data into small trucks and send all the trucks at one time, right? So there is some advantage, because when you are dividing the bandwidth to a smaller bandwidth, so now 10 megahertz is divided into 0.1 megahertz of bandwidth of each sub-band. So this goes under if you directly use a 10 megahertz bandwidth, I can transmit my data, but the problem is severity of the wireless communication channel. So channel creates a frequency selective channel. The frequency selective channel means if I am transmitting a signal, then because of the reflections from the several atmosphere present in the vegetation, the hill stations, the buildings, the chairs, human bodies, the material. So the wave propagation hits the material and it comes back. So when it comes back, it creates so many wavelengths, right? So many paths. So these all paths combine and coming to the receiver. So one path may be coming at one time, other path may be coming at another time. So we will call it as delta of T minus T1 is the one path. So summation Ti, I is equivalent to some I equal to 1 to 100 paths if I am receiving, right? So with an amplitude of Ai, the signal is coming. Then all these 100 paths will combine. So they may create some interference, destruction or construction is possible. So suppose 2, 4 paths are having a positive amplitude, 5, 6 paths are having a negative amplitude. Then what is the problem? Positive and negative, if you add them, so maybe remaining one path is only remaining, which is having a lesser value. May not be sufficient to decode your signals. That is called a frequency selective channel. So because of this frequency selective channel, we have to avoid the transmission of the entire signal at one time using a higher bandwidth. So we have to go for a lower bandwidth, where that is called orthogonal frequency division multiplexing, OFDM. So in OFDM, we divide the bands into sub-bands, and in each band now the bandwidth is reduced 0.1 megahertz. So for transmission of my bit, I can use a signal duration of t seconds. Okay? So this is my signal duration. Now, as how many signals you can transmit? Suppose if you are dividing this one into a smaller signal durations, I can transmit at least 5 symbols, right? So earlier I communicated only one symbol, now I am communicating 5 symbols. But the pulse width, how much pulse width I am creating? I am creating a smaller pulse width. So you know the relation between time and frequency. So time is inversely proportional to frequency. So if you use higher frequency, how much amount of time you have to use? You have to use a lesser time duration of the pulse width. So that is a problem in wide band communication. If you use the entire band at one time, we have to make your signals narrow and narrow and narrower. So when they are narrower, this frequency selective channel comes into play. But whereas if you increase the size of your pulse to a higher width, then we can avoid this frequency selective channel nature. We can make the channel as a flat fading channel. So in the flat fading channel, what is happening? So the pulses, if I am transmitting continuously, where I use a longer size of my pulse, so this pulse if I am transmitting, what I receive my pulses because of my duration, because of my distraction, because of my visitation, reflection, diffraction, I receive these kind of signal. So what is happening? Actually my T is now, this is my original T. From T it is added with some T dash, right? This is the additional time added to the pulse. But that additional time can be of a very small minute if you use a lower bandwidth of the signals. So I have a huge spectrum, so I have to communicate my signal. I divided my channel into sub-bands. So when I am using a smaller frequency, I can use a wider time duration for my signal transmission, that is called OFDM. So using the OFDM, you can eliminate frequency selective nature and channel becomes flat, so my decoding becomes very easy, right? That is the fundamental principle of my transmission scheme. So I will tell you a fundamental criteria for detection of a signal in digital communications. So in a digital communication, you might be talking about your BPSK, QPSK, QAM, PAM and many more, right? So and you also say that the spectrum is more, spectrum is less, the probability of error is more, probability of error of the signal received is less. These are all things we fashionate enough to derive the equations for a matched filter. This is my filter design, right? Everything we taught in the class. But what is the fundamental principle here we have to teach to the students is like this. So suppose I am transmitting a BPSK signal. I am starting from the fundamentals, right? I will transmit a BPSK signal, binary phase shift keying. What do you mean by binary phase shift keying? That means zeros and ones are coming. we'll translate them into minus 1, 1, 1, 1, minus 1, 1. Because 0 is not conveying any information, we translate into a minus 1. So for transmission of a minus 1, I transmit a negative symbol, negative duration of the signal. So this is for minus 1 and with an amplitude of certain A. For transmission of plus 1, I transmit a plus A for a duration of T, right? Then after that, because this is digital baseband digital modulation technique. So from this baseband digital modulation technique, can we transmit directly the pulse shape, give it to the antenna for the transmission scheme? No, because antenna need always an alternating current. So what should we do to create an alternating current? We multiply this pulse with a carrier wave, right? FC is called the carrier frequency. So we multiply with a carrier frequency. Then if you multiply with a carrier frequency, how many carrier frequencies are required? Only one carrier to represent, because anyway it is manipulated by the amplitude. So if I can create a one carrier of a cos wave form with a very high frequency, so this center frequency is 1 by Fc is the time period. So that means the frequency of this signal is Fc. So I can write cos 2 pi Fct is my carrier. It may be having some amplitude A or B or something like that. Or if you are maintaining a unit amplitude, I can discard cos B, right? So that means we have to multiply your pulse with a cos carrier frequency. So what is the pulse? The pulse is of a count minus 1 or plus 1 for a duration of capital time period T. That means your transmitted waveform, I will write it as S of T is, that means AI, right? AI cos 2 pi Fct is your time period. So this I will transmit for a duration of 0 to T to capital T. This is the way we have to start a digital communication course to the students. Then what is AI? This AI depends upon what I am transmitting from the amplitudes. If positive, positive amplitude multiplied by the carrier, that means I am transmitting this kind of a waveform. If A is a negative, then I will be transmitting a negative cos waveform like this. So these two are having a phase of 180 degrees, right? This is a digital modulation technique. So from this digital modulation technique, so many other digital modulation techniques are evolved, as because we have to send. Here only 2 bits, 1 bit at a time I am transmitting. But whereas in QPSK I am transmitting 2 bits at a time. In QAM I am transmitting many bits at a time, m number of bits at a time. So this is the way we have to explain to the students. Now, so this is the fundamental modulation technique. Now this modulation technique we are introducing into this band of a wider bandwidth. So each band is divided into orthogonal to 1 to 1. That means, so each one is having a center frequency of FCI, right? So this is having center frequency of also FCI, maybe I equal to 1. This one is FC of 2. So these two frequency components are orthogonal, means they stand in like this. They are vertical, 1 to 1. So that means if you compute a correlation between these two signals, the correlation between these two signals is 0. So what do you mean by correlation? Correlation means just multiplication of these signals. That means if I multiply cos Fc1 T into cos Fc2 into T, multiplication. So after multiplication means just multiply. Then after multiplication we have to integrate, we have to compute the area. So just integrate. After integration you will receive a value of 0. That is called orthogonality. That means these carriers are adjusted in such a way that they are orthogonal to 1 to 1, right? So when they are orthogonal, but still there is some leakage of your information. Then, so to avoid this leakage, we maintain some guard interval between the each band, okay? Now, I am going to use these modulation techniques for my 5G application or for my 6G application, right? So what is advanced topic in communications? So that is another advanced topic in communication is visible light communication. So in this room, we are sitting with a white LED lights, right? So there is a LEDs, collection of LEDs are provided inside your
trap and they are illuminating. They are illuminated by giving a power supply, right. So, what is the power supply? We are giving an AC power supply, it is converted into DC. So, diode takes only DC current, that fundamental principle everyone knows. So, this DC current flows, then the diode is forward biased and it is illuminating and giving a light to us. So, the same principle we want to use for the communication. Why we want to use for the communication? Because already the spectrum crunch, we cannot allocate a new spectrum, but the users are more and more every year. As per Cisco analysis, every year there is a trillions of users are adding to the network. Then how do you provide service to the users? Suppose in your university you are conducting a fest where you are inviting other colleges. So everyone want to use his mobile, right? So nowadays without mobile there is no life. Even if you are taking out your mobile for 5 minutes, I don't think you can happily take meditation and stand for 10 minutes. So without my mobile I am free. No, we don't feel like that. We need mobile for all the time. Except when you do the darshan in Tirumala Tirupati Devasthanam, so we have to deposit your mobiles. That time also while going on the queue, what is happening to mobile, what is my mail, how many messages I might have received, there might be a call from my HOD, there might be a call from my director. So this is thinking on even though we are in front of the God, right. So there is no life without mobile now. So that means we have to provide an alternate technology. So what is that alternate technology? Visible light communication is another alternative technology. This is going to become one of the use case in 6G. Okay. So we started this journey in 2016. So just in 2015 and the coin is raised by Harald Haas. So he was a professor that time at Edinburgh University. He raised a coin that why can't we use a light as a communication media? So yes, we can use it as a communication media, but what is the problem with the light? How to modulate your signals such that they are going through the light, right? And we receive from the light. So these are the two things. So how to modulate this signal? So for modulation of this signal, so I am going to present a visible light communication. So this comes under optical wireless communication. Frankly speaking, we are not using any optics. We are using only optical devices. For the transmitter, we use a diode. For the receiver, we use a photodetector. So how many of you have learned about a diode and a photodetector in your second year class? So I think many of the students are students only, right? So I can see your faces. How many of you have used diode experiment? Forward bias, reverse bias, you have done, right? So forward bias, diode can conduct only in the forward direction. It cannot conduct in the reverse direction. But for my modulation schemes, what I explained earlier, it is I have to send a carrier waveform. Suppose a binary BPSK signal, if I want to transmit, I have to transmit a carrier waveform with a positive side or a negative amplitude. Only the amplitude of the carrier wave is going to change, depends upon bits I am transmitting, right. So then is it possible, can we transmit this kind of waveforms through a diode? The fundamental question. Can we transmit a carrier waveform of the waveform which I presented earlier? If you give this kind of a waveform to a diode, what is your output? What is your output? Because you are already in third year or second year? Final year?
Some students final years, some students are research scholars.
Research scholars, at least research scholars. So what is the output if I am giving a cos waveform to the diode? You have done a half-wave rectifier experiment, right? So what is your output, expected output? So from the expected output, during the positive half cycle, the diode conducts. During the negative half cycle, diode is not conducting. Then how can you do the communication with a LED, visible light communication? I have two devices available. I can use simultaneously for communication and illumination. But if you have to transmit a carrier wave of different amplitudes, is it possible to communicate? No, it cannot be possible. But you can give a thought. Why can't we make your entire carrier waveform to shift to the positive side? right? Possible? We can shift to the positive side, we can communicate, right? So this is my presentation today. So I will be talking about VLC characteristics, modulations, the test bed what we developed at our institute, not only for visible light, we have developed the test bed for GFDM, OFDM, for 5G use cases, and even for 6G, OTFS also we have developed a test bed. We can show the real communication, how it is happening, and what are the achieved results. And so this visible light communication spectrum, if you look at, it is having a huge spectrum from 400 nanometers to 700 nanometers in the wavelength. So this is the huge spectrum is available, but the limitation is only the diode. The diode is only the limitation. Diode cannot accommodate your waveforms. So if you have, so the research directions are going in widespread nature. Some people are working on materials, how to design your diode such that it can accommodate continuous fast switching of the waveform. Some people like us, we are working on the modulation schemes. Some people like others, they are working on the networking issues. Some people are working on the whole system design. Some people working on the stack design. So many research areas are present in visible light communication. So this is the wide spectrum is available. This lies between infrared and ultraviolet range. So you know very well, infrared, your remote, TV remote is functioning on infrared based on the light. So after that light, we have a visible light. After that, we have a ultraviolet. So ultraviolet is used for scanning of your bodies, right? So this is the coin. Then, so we can use this optical devices signal. So only problem is that signal must be a real signal which we can feed it to the diode. So we have to make your communication system, because you might have given some theory about your QPSK communication. So in the QPSK system, so you have derived your constellation diagram with 4 points. So one for 0, 0, 0, 1, 1, 0, 1, 1, right? So it has an x-axis point, it has an y-axis point. So that means it is in the form of a plus some j beta. That means it is a complex in nature, right? We have to create this kind of a waveform, a complex in nature. But can your diode can take a complex signal? No, it can take only real signal. So we have to do your modulation techniques. Nature has to be translated into complex nature to a real nature. So that is where we have to work on. So for that, so what is the system? It is called intensity modulation, IM, and detection is called direct detection, because the light falls on the diode, photodiode. So we are transmitting a signal from the diode. So light is coming. This light travels and it falls on a photodiode where you are keeping it as a receiver. So that receiver accumulates the light source and converts into electrical source. That will be your, somehow you have to do the manipulations to receive your original signal, right? So this is the technique where we use. That means it is intensity modulation and direct detection. So the transmitted signal must be only unipolar. Why unipolar? We have to make the signal, suppose if you are transmitting a positive bit, my carrier waveform will be something like this for a duration of capital T time period, right? But now it is having a plus A amplitude and a minus A amplitude. So it is not allowed, because if you transmit this kind of signal, only positive signals are transmitted and negative signals are cut off. That means if you pass the signal through a diode, we will receive only this kind of a waveform, where we are missing your information, right? So to manipulate this signal, what we do, we add some DC bias. This is my DC bias. So if you add a DC bias to this, then this will be shifted to a value of positive, where we should avoid cutting off your lower edge. Okay, that is a technique we have to adopt to use your LED as a light emitting source as a transmitter. Okay, so now we will see how to do this light emitting source as a diode. So these are the so many modulation techniques available in literature. on-off keying, pulse width modulation, PAM, multi-PAM, DFT OFDM, color amplitude positivity, DCO OFDM, ACO OFDM, PAM. So that is the multi-carrier signal, single carrier signal, other multi-carrier techniques using a hard mode coded modulation techniques, WPDM, DHT. So many modulation techniques are there, right? So, but we will concentrate on only some of the basics, not some of the basics, even advanced version of modulation schemes. So, I will be talking about some of the multi-carrier because our session is on multi-carrier. So, I will be talking about OFDM multi-carrier technique. So, upon the OFDM multi-carrier technique, I stress upon DCO OFDM, ACO OFDM. It is a normal wireless communication, it is only OFDM. But if it is a visible light communication, then it is called DCO, direct current optical OFDM. Why direct current? I have added some additional DC bias. So, that is why it is called a direct current optical OFDM communication system. ACO OFDM, asymmetrically clipped optical OFDM. This is another modulation technique. So, we have explored most of the modulation techniques which are present in this slide. Almost all modulation techniques we have tested, verified using a real communication test bed. So, now look at a transmitter scheme, how we have to design. No one is using pen, no one is using your notepad. So, which is I object if people are sitting in my class. Everyone must use your pen and notebook when a teacher is explaining a lecture. Even a teacher is also sitting in the class, I will insist all of them must use their pen and notebook. So, without pen and notebook, because your whole body concentration comes only with use of pen and notebook. Your mind has to work, your hand has to work, your body must be present in a correct position, right. So, that is why many of my students of BTech, NIT Warangal students, they are afraid of my lecture. So, in front of me they act like a smart student, but out of my class they play so many jokes about Mani madam because she is very strict in the class. So, I do not allow if they are talking each other, I do not allow if they are doing any cheating business, I do not allow if they are looking at their phone. So, I make everyone has to carry his own notebook, every day I check their notebooks. I go to them, if I have a doubt I go to them. I can judge by looking at the faces, who is having a real student, who is not sparing his time, right. So, please always use, that is why where we are lacking in our education system from foreign countries to the Indian countries. So, I said about my brother, right, they are studying in foreign universities. So, their education system is so much designed in such a way, but because of the lot of freedom given to them, they are getting spoiled. Otherwise, there is a very good education system. They learn everything by practical. They write their English poems, you do not believe. 100 times they write the same English poems, they underline with color pencils and each phrase again they will write a separate note. So, how much hard work they are doing? Are we doing the same? No. Teacher is teaching and you are going away. That is it. That closes the business. So, this is an optical OFDM system where your source data, that is, just now I said no, it is your modulation scheme. So, BPSK, QPSK, so source bits are coming, we translate into a modulation format, either here I used a QAM, but you can use a BPSK, right. Then after that we have to pass this signal to a multi-carrier system. That means we have to divide your bands into sub-bands, like one of the example is orthogonal frequency division multiplexing. So, we do the sub-carrier alignment, then for orthogonal frequency division multiplexing use IFFT modulation, IFFT as the source and we do add cyclic prefix, then finally we will convert into unipolar because our system is bipolar. So, we have to convert into only one direction, that is all the signals must be converted into a positive sided signals. Then we use the optical device as a transmitter, that is nothing but your diode. Okay. then it passes through the channel, that means, and also added by additive white Gaussian noise. Then after passing through the channel, we kept a photodiode. So light falls on the photodiode, that is an optical receiver. Then the reverse process of OFDM is, we'll remove the cyclic prefix and we do the demodulation using FFT, and we do the subcarrier extraction, and we do the QAM demodulator, then we'll move it to the data sync. Okay? Why IFFT and FFT? Yes, as I'll explain mathematically what is happening over here. So, very good question. Why IFFT? So you know the formula of IFFT, right? So what is IFFT? It is an inverse fast Fourier transform. So if you know the inverse fast Fourier transform, the input bits are given, that is my x of n. Inverse fast Fourier transform means e power minus j 2 pi k sum n by capital N, right? So generally we write e power j 2 pi ft. This is the principle. So now t is translated into e power j 2 pi, because it is a digital modulation scheme, we have to do the sampling. So the frequency, maybe I will write it as fi, then n times ts, right? So e power j 2 pi n times fi by ts means fs, right? So this fi by fs ratio, if I write, what is my original frequency, what is my sampling frequency? Generally, how do you do the sampling of a signal for a given signal? What is the Nyquist rate? Only students should answer, not the teachers. What is the sampling? What is the Nyquist rate? Fs must be greater than or equivalent to the frequency present in the signal, 2 Fm, right? Or 2 Fi. So that means, suppose if I am fixing Fs as equivalent to 2 Fi. So what is happening over here? That means Fi by 2 Fi, right? So that is FIF gets cancelled, it's only the ratio of 2. So who stopped you to make only 2 Fi? I can make n Fi, right? So that means if you do n Fi, then this will become 1 by times n, correct? So that means in my expression, I can write what is 1 by, I already presented by n. So this by n is coming because of your how many more sub bands we are using. So then what is the first band, what is the second band, what is the third band? So e power j 2 pi k times n by small n by n, right? That is the formula for FFT. But I am using for IFFT, we have to use a plus sign, right? So then what is the value, the resultant value? So that means, and one more question you should ask. I wrote x of small x of n. So for FFT, because earlier I started with FFT with a minus sign. So frequency, what is FFT? Fast Fourier transform or discrete Fourier transform. For discrete Fourier transform means we have to give input as a time signal. The output will be frequency signal. So what is the time domain signal? Generally we represent time domain signal by small x of the value, right? That is why I use small x of n. I started with FFT, but now I am starting with IFFT. So here what I am giving as an input to my system is I have to develop n orthogonal carrier frequencies. So which is possible through your IFFT scheme or FFT scheme. So what is FFT? FFT is taking the input and multiplying with sum of n orthogonal carriers, e power j 2 pi k n by capital N. That k is kth orthogonal carrier, nth orthogonal carrier. Like that, how many carriers I have to sum up? 0 to n minus 1, right? So that is the DFT equation. But I am going to for modulation, so I am just writing what is DFT, what is FFT in your case. FFT is x of k, it is a frequency domain signal, is equivalent to sum of n equal to 0 to capital N minus 1, x of n e power minus j 2 pi k n by capital N. Satisfied? This is a DFT equation. So in this DFT, how many number of orthogonal, so the total number of carriers are divided by n. What is each n is represented by small n. This is my FFT signal. So now what is the input? Input is time domain signal. So for my frequency modulation, so here I am using IFFT block, not the FFT block. This is a fundamental question everyone will ask if you really understood the problem. If you have really understood the problem, everyone may ask why it is IFFT rather than FFT, right? So here what is happening? Because, so this is my FFT. Now I am writing for IFFT. So IFFT or IDFT for time being. So IFFT, what is the output of my IFFT computation? It is a time domain signal, right? That means my x of n is equivalent to summation of k equal to 0 to capital N minus 1, x of k how to substitute? E power j 2 pi k n by capital N, only positive and negative, right? Now you have to understand, I am giving x of k as my input. So x of k means my data bits 1, minus 1, 1, 1, minus 1, minus 1. These are my data input bits. So they are multiplied by orthogonal carriers. So this data bit k equal to 0 data bit is multiplied by e power j 2 pi k n by capital N. So to obtain an nth signal, I have to multiply it by k equal to 1, 0, right? So that means I can compute x of 0, x of 1, like that x of capital N minus 1. So to obtain x of 0, how many carriers I have to multiply? I am multiplying all the k number of bits are multiplied with different values of k's. That summation is coming as your x of 0. That is one OFDM symbol. That is called one OFDM symbol, right? So we understood we have to transmit over n orthogonal carriers. Onto this n orthogonal carriers, I have to give the input data bits. What are the input data bits? My minus 1s and plus 1s. So because I am transmitting at one time. So that means n number of data bits are multiplied with n number of subcarriers, are added everything, then we pushing onto the channel. That is the original meaning of IFFT. So bits are in the frequency domain is no problem. It is only plus and minus 1. Okay? If you use a minus sign, DFT, then you are creating the output as the frequency domain. But ultimately what you have to transmit? You have to transmit only a time domain signal. So that is why we start with IFFT, not with the DFT. Understood? So in any general presentations, if you ask such kind of questions to the faculty, maybe they are attaining after 10 years or 15 years or 20 years of experience, they cannot write simple equations and cannot explain to the students. Damn sure. I have seen my own faculty. Why? Because nowadays faculty are habituated to use only PPT. Without PPT, the life is gone. That's it. Today, if the power shut down, we'll close the business, bye-bye, and go to your canteen, go to your wherever the places you are interested, because we are in the government sector. But private sector, I don't know how it is happening. Maybe if you are habituated to teach through PPT, these are the major problems. So unless you write each point of equation, it won't go into your mind. That is why I am always stressing my students use notebook and pen. If I am seeing without notebook and pen, I will make them to stand in the class itself for the entire 1 hour. They cannot leave the class. They have to stand along with me and they have to write. Certain areas we have to focus very severely to control the mechanism. Certain areas we have to motivate. In certain areas we have to praise. where we have to price, where we have to motivate, where we have to keep the punishments. These are our learning experiences. It will come with the learning process. So now I understood the modulation scheme, and why I am using FFT for the demodulation, because I have given output is x of n, that x of n is coming to FFT demodulation. So that means that is a time domain signal. From the time domain signal, what it will convert? Frequency. For me, no problem, because originally I thought x of k's are in the frequency. So the coming output used to be a time domain, is not a problem. Okay. So now in this case, I am talking about DCO OFDM, direct current optical OFDM. So how many of you are the faculty here teaching signals and systems class? 1, 2, 3. Do you use PPT or do you use board writing? Board writing. So how many times you have confused yourself about, I'll ask a fundamental question. X of t is given. Now I am asking x of a t plus k. There are two methods. One is shifting, other one is scaling. So shifting is independent of scaling. First we can do the shift operation. That means x of t is given, then I will shift it to x of t plus k, right? After shifting my signal, original signal. Suppose I have a signal of this fashion for 0 to t or 0 to 2 with a value like this. Suppose k equal to 2, that means x of t plus 2 shift. So then if it is a right hand side shift or a left hand side shift, it is a right hand side shift. When it is RHS, we have to subtract from the original value, that means minus 2, minus 2, minus 2. So it starts from minus 2, 1 minus 2 is minus 1, 2 minus 2 is 0, right? So that means your signal will start at minus 2, minus 1, 0. This is called left hand side shift, not the right hand side shift. Left hand side shift, right? After shifting, I am asking the question x of 2t plus 2. So I already did x of t plus 2, right? Now I have to do the scaling. So which scaling? So this one I have to model it as x of 2t plus 2 format. That means wherever the time domain is there, that I divided by this a. What is a? A is 2 by 2 by 2 by 2. That means I will get minus 1, minus 1, minus 0.5 and 0. That means your signal is now, it is at 0 and 0.5 and 1. So the size is decreased, right? So now the same thing we can do it in another alternate method. So because first I shifted the signal, then I scaled up. So the another procedure is x of 2t plus 2, I can make x of 2 times t plus 2 by 2 common, then x of 2 times t plus 1, this is my answer. Now if you do this procedure, to which extent you have to shift? First will you do the shift or first will you do the scaling? This is also correct, right? X of 2t plus 1, 2 as common. So which operation will you do? The first operation is, we learned shift is independent of scaling. So I can do the shift, no problem. Later I made a scaling procedure. Now you tell me, I made a common, now shift value is reduced to half. So earlier 2, now it is 1. Now if you will you do the shifting first, then scaling, or first scaling, then shifting? Please execute, otherwise I don't continue my talk. People talk so many things, but without knowing the fundamentals, if you go deep into first scale and then shift. Please continue. First scale. So what is the procedure for first scale? So my original signal, again for the second case, I am putting my original signal as, so 0, 1 and 2. So what she said is first scale. So suppose that means I am computing, this is my x of t, now I am computing x of 2t, correct? Scaling is 2t, so I am doing x of 2t. So 2t means you divide by 2, by 2, by 2. What is the answer? 0.5 and it is 1, right? So if you draw the waveform, so it will be around this point, 0.5 and 1. First scaling is done. After scaling, that means x of 2 into t plus 1, right? So what is plus 1? Plus 1 is a negative shift. So negative shift means you have to add or subtract. You have to add or subtract. You have to subtract. So if it is subtraction, then I will just subtract with minus 1, minus 1, minus 1. What is my result? It is minus 1 minus 0.5, it is 0. So accordingly, what is my resultant output? 0, minus 0.5 and minus 1. So this is my output, right? So just match with the first output and second output. So minus 1 and 0. So how much struggle I made to explain the concept? I showed that both the procedures are correct, but there are certain common things we have to make, right? So if the same technique, if you explain through your PPT, will it go into the student mind? Will it go into at least the faculty mind? What is happening? It will not go. So that is why we have to always make a habit of writing with the pen. Even if you use your notepad, or even if you use your mobile tab, anything, use a pen always, right? So you write something in your note. So in every app there is a one note is there, in every mobile there is a one note is there. So use a note, writing, make a habit of writing. So that is the way we are controlling your mind. That is the way you are managing your entire system to stand in front of the members. This is the fundamental principle all the time, your entire life you have to remember. Okay, so then, now DCO OFDM, direct current optical OFDM. So here in this DCO OFDM, what I am saying, because IFFT, right? IFFT is for generating n number of subcarriers, e power j 2 pi kn by capital N, n number of subcarriers we are generating. So in those subcarriers, what we are going to do to make the signal as a real signal, we are imposing Hermitian symmetry, because our ultimate goal is from the output of the modulator should make it as only real, no complex domain, real and unipolar in only one dimension, right? So to make it one dimension, anyway we add some DC bias, that is not a problem, but also we have to make sure that that complex nature of the signal must be avoided. We have to make only, if it is of the form A plus J beta, we have to make it as only A or some A dash, that is the principle. So to make into this format, we use a Hermitian symmetry. Just have a look at Hermitian symmetry. So in this Hermitian symmetry, shown with a symbol diagram, suppose there are how many subcarriers a system is divided? Consider each one block. Each one block, how many subcarriers are there? 1, 2, 3, 4, 5, 6, 7, 8 subcarriers. So that means my capital N equal to 8. My capital, please write my capital N equal to 8. So in this capital N equal to 8, now just see that I am transmitting x1, x2, x3. x1 means my x of k, capital K, right? So where k equal to 1, 2, 3. So in the first subcarrier, I am using a DC voltage. DC voltage. In the first subcarrier, so one person is not writing anything. Are you faculty or a student? Yourself. student or a faculty? Where is your notebook? Writing? Okay. So, DC x1, x2, x3 and the center carrier we just made it as 0. And remaining carriers we are making complex conjugates of the first subcarriers. So, out of n, now we can imagine, out of n subcarriers, only half subcarriers are efficiently used. Why? So, here x1, x2, x3, right. So, one subcarrier is gone for DC and center subcarrier we made, we are not transmitting anything, and remaining subcarriers only what is present and the first, just making a complex conjugate. So, at present suppose x1 is a plus j beta, then what is x1 conjugate at the last? It becomes a minus j beta. x2 is suppose a dash plus j times b dash, then what is x2 conjugate? Minus. So, here positive values and the complex conjugates of their values are also placed in this system, right. So, this makes, that means your data symbols, this kind of an arrangement, if you give it to the your OFDM IFFT block, if you really compute using your DSP, the output will be only the real signal. I will show you the output. But out of n subcarriers, how many effectively we are using? N by 2 only. Half the subcarriers only duplication of your signals to make the signal into a real format, right. So, that means your spectral efficiency is going down, but we could able to make your signal into a real format. That is this modulation technique about. So, and asymmetrically clipped OFDM. 5 minutes, huh? Okay. Okay. So, in my class, if I announce a break, I always make a practice of stand, sit for 5 times. That is only the break. But here anyway faculty members are there, so I cannot do the same exercise. So, but my students love it. So, it is a challenging task in front of the students to take up the subject, especially IITs and NIT system. So, as I did my PhD from IIT Delhi, we are having a teaching assistantship. For that we are being paid with a scholarship, and parallelly I can do my research. So, this for this payment I have to work weekly 6 hours. I have to take tutorials to the BTech students. So, if you raise, if I put an equation, they raise 100 questions. So, they really make you to dance, but we learn from the system. So, that was helped me in my teaching a lot. So, once I joined with NIT Warangal, so these students, even I found that they are more sharper than IIT students, but somehow we do not know what was happened in the examination. So, they were into NIT system. Even they used to ask hundreds of questions when I write, especially I love teaching signals and systems, I love teaching all communication subjects, probability theory, wireless communication. So, in my entire career I taught nearly 17 subjects of different variation. Now, this semester I am taking quantum communication. It is entirely a new subject for me. I do not know how I will start, but I will start. Okay. So, I have to learn mechanics, I have to learn quantum, I have to learn computing, I have to learn communication, I have to learn sensing, finalize everything, give a grasp, try to make it to understandable format to a student, and definitely they raise hundreds of questions. If you are unable to tell them, then they will keep a brand. Maybe in front of us they praise, out of the class everything knows, right. So,
Sample size ready to be taken. We are taking one should be DC, that means this by DC biasing we can make it as a positive.
Okay. So again, come back to the next modulation scheme, that is asymmetrically clipped optical OFDM, the second version. So here if you have a look at the second version, how many subcarriers we are effectively using? Earlier 8, out of 8 only 4 we have used, right? Now also 8, but from 8 we have reduced to only 2. Effectively we are using n by 2, now it has become n by 4. Effectively we are using. So here what we are doing, every alternate position we are not transmitting anything. And also the same symmetry, Hermitian symmetry. Hermitian symmetry means complex conjugates. Half the subcarriers are your data, remaining half subcarriers are equipped with only complex data. So the spectral efficiency is further reduced, but it is a more effective way of doing it, right? And another modulation scheme is pulse amplitude modulation, DMT. What is DMT? DMT, even I also don't know DMT. DMT. So this one, pulse amplitude modulation, digital modulation technique, madam is saying, may be correct, slightly, okay. So we will come to know. So in this DMT, P1, P2, P3 and just reverse, P3, P2, P1. So only 2 subcarriers we are not using, the first one and the middle one, okay. The same values we are placing twice the time. So this is where we published one paper. So this is the arrangement of symbols in optical OFDM based modulation schemes. So we are making the signal into real format, but at the same time the spectral efficiency is reduced from one modulation scheme to the other modulation scheme. Okay. So just have a look at the test bed what we have designed. Okay, before to that, so what the test bed we have designed at NIT Warangal to show our visible light communication is happening in real time. Okay. So one of my students, this is from our funded project, funded by SER. So this where what we have done, the green portions, LED driver designed by us, and LED. So with some thought, my student just opened the light and he totally removed all the LEDs present inside a single lamp. So we used one of the LED as for our experimentation. But another one is, so here what we have developed is, there is another software called LabVIEW. We have used MATLAB and also LabVIEW. The advantage of using LabVIEW is, we can write the entire code in the software, right? Your data generation, IFFT generation, then modulator, that is data generation, QAM or PAM or whatever modulation you are using, then send them onto the IFFT block and add a cyclic prefix, right? Then transmit through your LED. So the beginning block, so data source, we have used a pulse amplitude modulator, and up sampling we have used, then pulse amplitude modulator, each pulse, how I am shaping it, like a rectangular pulse I said, right? So but rectangular pulse, the bandwidth of the pulse, because it is bounded by 2 limits, between 0 to t, this is a square waveform. So for a square waveform, for rectangular pulse, if you compute Fourier transform, what is the Fourier transform of a square waveform, a rectangular waveform? It is a sink. So in time domain, the rectangular pulse is between minus t by 2 to t by 2 or from 0 to t. In the frequency domain, if you compute the frequency domain, the spectrum is infinitely large in the bandwidth. right? It has a main lobe, side lobes continuously increasing to a large value. That means it will occupy a large bandwidth which is not available for us. So we have to shape the pulse in such a way that it occupies only limited band. So we use the pulse shaping filter. Then we have given this code to my USRP, Universal Software Radio Platform. So these are the boxes, dabbas. We bought from NI, National Instruments. So what it does, so you develop your code in the software, I do my hardware part. So just give this software code to this box. So this box creates a circuit diagram. So what you have generated from in the LabVIEW PC. So what a great advantage, right? I need not build each circuit block. Like data generation, I have to generate a circuit block. For QAM modulator, I have to design a circuit. For IFFT block, I have to design a circuit. I need not do it. Only everything I write in the code. So then this code is given to USRP. USRP will generate a FPGA based circuit diagram. No, we need LabVIEW license, we need hardware USRP. So this comes in a budget of USRPs maybe around 4 lakhs, but we need 2 USRPs, one is transmitter, one is receiver, so 8 lakhs, and each license of LabVIEW is officially, if you buy it is each license maybe 1 lakh. So at least 2 licenses if you bought within a 10 lakh, we can show the experiment, right? So if that budget is allocated from your university. So, so this one in the LabVIEW, that means it's a baseband design. So this is called a baseband design. I have not considered any frequencies, I have not created any other format, only a rectangular waveform is generated for a duration of t, given to the according to the modulation scheme we have generated, and pulse shaping filter. Then this USRP converts into a high frequency band. I said no, the positive amplitude must be multiplied with a carrier. So that is done by your USRP, and also it builds a circuit diagram inside, a software defined circuit diagram. Then that USRP has a transmitting antenna and a receiving antenna. Just have a look at, this is the USRP box. So this USRP has RFA, can you see the RFA? So there is a TXRX, there is also RX2, and this side is TXRX, RX2. So that means I will connect antenna at this point, we will use an antenna. So and for receiver also we will use an antenna. And so 2 transmitters and 2 receivers. You can make a MIMO kind of a communication, multiple antenna and multiple output, okay. So we have used this one, and then we have designed a bias T. Just have a look at bias T, the purpose of bias T here. So what is the bias T is doing? There is an RF waveform is coming. To shift the RF waveform to the positive side, we have to add a DC bias, right? That means two waveforms we have to mix. So that means DC upon DC I have to add AC. So these 2 different waveforms I have to mix them up. So to mix, that means my circuit in such a way that it is a kind of a bias T. It takes 2 input, it gives me 1 output. It is like a T. It takes 2 input and gives me 1 output. It is a bias T, that is called bias T. So we bought the bias T, and we have added a DC bias, which is currently available in your DC box. What is the DC box is called? Regulated power supply, RPS. So that is your RPS is used, everything is available in the laboratory. Then we have designed a driver circuit. Why driver circuit is important? Here because the light emitting diode has a limited capability of transmission of the signal. So based on the design, the manufacturer has designed your diodes for certain cut-in voltage. Then after cut-in voltage, it can handle only certain amount of current. So what is that current? It is called in the active region of your diode characteristics. Do you remember your active region of the diode characteristics? So once the cut-in starts, it will take only this much of variation. if your current varies in between this region only, your diode conducts, otherwise it go into the saturation region, it will not conduct, right. So, we have to maintain such region. So, I have a large amount of voltage, so where I want to give, so that I will attain a good amount of output, it is not possible. We have to restrict yourself in the limited domain of your diode only. There is a major restriction on visible light communication. So, that is why people are working on the materials. So, which material to be used, so that it makes fast switching. So, because if you use a carrier frequency, very high carrier frequency of megahertz of range, then it has to change from positive to negative, negative to positive, right. Very quickly it has to oscillate. So, the current LEDs, there is no provision of oscillating very fastly. So, there is a restriction on visible light communication. So, with that we have designed an LED driver which makes a fast switching action such that it is limited to only my diode operating characteristics. Then we will pass the signal to the optical channel. So, what is the receiver used here? It is a photodiode. The channel is only wireless channel. So, this is, I will show you the diagram. This is a transmitter section, we placed a receiver over there. So, entire one is only wireless communication, there is no wired communication. So, then we have used a photodiode. So, to obtain this photodiode from Thar Labs, we spent nearly 8 months of our time to buy one single photodiode from Thar Labs. So, which has to be imported from US. So, there is an import duty, they do not directly make a courier to Indian organization, right. We struggled a lot to buy this photodiode, but we are successful. This diode itself has a transimpedance some amplifier inside built in. Then we will give the received signal, light falls on the photodiode, received signal is given to again USRP. What the USRP does now? The up converted signal, that means first it will remove the carrier, right. So, then after removing the carrier, we learned what is a matched filter, because we have transmitted the matched filter concept. So, we are transmitting a signal in the base band for a duration of t, if it is for positive amplitude or a negative amplitude, right, if it is a BPSK signal. So, in the communication, we have transmitted this kind of a waveform, a carrier waveform. You remember? This kind of a waveform. So, that waveform is given to your USRP. Now, what the USRP does? That removes the carrier. Removes the carrier. What is remaining now? It is remaining only amplitudes, plus and minus amplitudes for a certain duration of time. Now, I have to track wirelessly what was transmitted. That means, I send hundreds of bits. Out of hundreds of bits, how many bits are received correctly? That says, that gives you bit error rate. So, 100 bits, out of 100, suppose 2 bits gone wrong. Then what is the bit error rate? 2 by 100. That means 0.02. So, if you tell in decibels, so we will compute 10 log 10 of BER. So, 10 log 10 of 0.02. What is the value? 10 log 10 of 0.02. Generally, we tell BER in 10 power 0, 10 power 1, 10 power minus 1, 10 power minus 2, 10 power minus 4, like that. So, that means out of 10,000 bits, 10 to the power of minus 4, the meaning is out of 10,000 bits, 1 bit is gone wrong, is acceptable in the communication. But out of 100 bits, 2 bits gone wrong is not acceptable. So, we have to achieve a lower bit error rate. BER is to be very low. That means 10 to the power of minus 6, 10 to the power of minus 8 is acceptable in the real time communication. So, here we use for the detection of these signals. So, continuous stream of data is coming. Then from that stream of data, I have to, maybe it is the signal is of this format is coming at the USRP after removing the up converted signals. So, we are receiving this kind of a signal. Now, I have to identify bits, right. So, what is the procedure we have to adopt? We have to use a matched filter, we have learned in your digital communication course. So, what is a matched filter? A filter which is matched. There is a physical meaning. A filter which is matched we have to design as a receiver. So, I will design my receiver now, the concept of a matched filter. So, to detect this one as a positive, if it is positive, I will decode it as bit 1, right. If it is negative, I will decode it as bit 0. That is a simple principle. That means, what I do, I multiply with a filter which is matched to my pulse. This is called a matched filter. So, when I am multiplying these two, what is the output? When I am multiplying these two, like this pulse and this pulse. So, this is x of t, right. This one is also I am designing as same as x of t. This is available for 0 to t. Then I do the matched filter. That means, x of t minus tau. Suppose the tau equal to 0 from 0 to t dt. This is my matched filter, right. It is a convolution, the convolution principle. So, this is my matched filter, that. So, when both are matching 1 to 1, if both are matching 1 to 1, that means if x of t multiplied with x of t from 0 to t dt, what is happening? X of t is 1, 1 multiplied by 1 for the interval of 0 to t. So, the maximum value I will obtain at the value of t, that means it is convolution between these two waveforms. When you do the convolution between two rectangular waveforms, so if anyone asks between the two rectangular waveforms of 0 to t, then I know the convolution formula. The total time duration of my convolution will be t plus t, that means it will be 2t. At t, I will obtain a maximum value of t at t. This is my output exactly at t. That is the principle of a matched filter, right. So, just exactly at capital T, if I am sampling, I am getting the maximum value. If I am sampling at less than t, greater than t, my output is minimum. So, I have to sample exactly at capital T, then I will obtain a maximum output from the signal. So, this maximum output depends upon if a positive signal is received, convolved with a positive signal, I will get a positive signal output, convolved output. So, then if it is positive, I will map it to bit 1. If a positive pulse is convolved with a negative, suppose my received signal is negative, a negative pulse convolved with a positive pulse. What is the convolution output? It is a reverse triangle, right. So, negative voltage. If it is negative, just I will take that magnitude of the signal. Is it a positive sign or a negative sign? If it is positive, I will map it to 1. If it is negative, I will map it to 0. That is the principle of matched filter. Okay. So, we do matched filter and also proposed with timing estimation problem. Why it is important timing estimation problem? Timing estimation because both transmitter and receiver are at different locations. Each one is having working at their own clock. So, you are working with your clock, I am working with my clock. So, your time is different, my time may be different, right. So, when in this wireless communication scenario, the signal is received at the receiver. So, I have transmitted my signal at 0 instant. Because of the multipath communication, it is reaching your transmitter at some t 0 plus some tau, right. So, now you have to start your detection exactly at 0, because I know that I have transmitted at 0, but because of this multipath it is getting delayed by a tau. But what do you do generally? You start your detection at exactly at 0. So, between 0 to t there is no received output. What will you receive? That means your entire detection scheme is going wrong with a tau delay. So, unless you identify the tau where exactly I am receiving, I cannot receive my exact output. So, we have to identify what is the tau I have to start at the receiver. That is called synchronization. So, very important in wireless communication, synchronization issue. So, your mobile is also having a synchronization algorithms. Your laptop is also having a synchronization algorithm. So, it works with a synchronization algorithm. So, how it works, the synchronization algorithm? So I start my window like a window session. So I have, let us assume that I transmitted all positive pulses like this for a duration of t. So I have transmitted 3 symbols, right? That means it takes 3t. So this is my transmitted signal. Now I am working at the receiver. So it's, I start my receiver at 0 position, right? What I do to make the synchronization, so initially I send known signals first. So these are known signals, 1, 1, 1 is my known signal. But my receiver is having some delay of tau. So it will receive at this point. Let us assume that there is no multipath, simply has a delay. So that means t plus tau dash, 2t plus tau dash, 3t plus tau dash. This is my received signal. How much delay is there between these two? This is my tau. We have to identify that. Where I have to start my reception. If I start my reception exactly at 0, so I am doing matched filtering. So that means the received signal is positive, I multiply with a matched filter. So then, but what is happening? So there is no value at this point, only it is available from tau dash to tau dash plus t, right? So, but I am multiplying at this situation maybe like this. So can I get a maximum output? I don't get a maximum output. So slowly what we do, we keep a sliding window at the receiver. We keep a sliding window. So what we will do, I receive with a small pulse. So this pulse, I keep this, this one multiplied with the received signal. So there is no input at this point, right? So that means my output is 0. Slowly I will move my window to the next position. What is happening now? I multiplication of this window with this window. There is a correlation. So I will receive some amount. Like that I will move my window till where the maximum value I am getting. So unless I move my window up to this point, I don't get a maximum value, right? So here I will get a maximum value between these two, because rectangle, rectangle. So that means this is my tau value I will identify. There are several techniques for synchronization issue. This is one of the example I said. There is a CP based, this is a, other techniques are also available with preamble, without preamble, so many techniques are available. So this is one of the example I am saying. So with this, we have done a proposed timing estimation. This is a different estimation technique we have used. Then downsample, then demodulator and a data sync. So this is the way we have designed a wireless test bed. Just have a look at the wireless test bed, what we have designed at the NIT Warangal. So please have a look at, does your USRPs have any antennas? We removed the antennas, because here we are not using an antenna communication. We are using only light communication, right? So TX USRP, RX USRP, they are, 2 USRPs are visible. So one USRP is connected with LabVIEW PC. So software is there in my system. So another USRP is connected with another PC. So LabVIEW is installed in the another software. I have designed whole of my modulation scheme in the LabVIEW, transmitter LabVIEW. So dumped onto the USRP. The USRP, can you see a light glowing at the transmitter? So we have placed a small LED, very small LED for a practical purpose. You can see the bias T having 3 junctions. It takes 2 inputs and 1 output, right? There is a connection, no? It's not visible, right? Can you see it? Right? So from the bias T, so this is the light, and photodiode is placed on top of a stand. This is the receiver. That one is the receiver. This one is my, so from the LED, and there is an RPS, regulated power supply, because we have to keep your LED on. Can you see LED over here in the board? This is the LED driver circuit. So to this driver we connected one LED, which is glowing, is not clearly visible in this diagram. So this light is from USRP light, not my LED, sorry, this is not my LED. So LED is there in the circuit diagram. This is the driver circuit, so LED placed in the driver circuit, right. So then we placed for a line of sight communication, we placed a photodiode on top of the this one. So these are all connected with our regulated power supply, because LED need a regulated power supply. So and diode, photodiode also need a regulated power supply. So this is my receiver USRP, and you can see the constellation diagram. The transmitter constellation diagram using a PAM or using a BPSK. So this is using a BPSK modulation scheme, or using a PAM also, no problem. Okay. So now, so we have received. This is my received signal. You can see the constellation diagram difference. The transmitted points are located exactly at their locations, but the receiver point is scattered around, because it is added with additive wide Gaussian noise and the channel noise. That is another problem. So the ambient light which falls on your system also detects some amount of current. So we have conducted this experiment by switching off all the lights. It's a very good question. So there is another area where people are working, how to keep filters such that another ambient noise will not affect your communication. Suppose I want to place this, the whole setup in the outdoor, it will not work, because sunlight is directly falling, right. So that's not your real communication. So lot of research is happening in this area. So we switched off the lights and we conducted the experiment. So you can see the transmitter and receiver section. We have USRP N210. So many USRPs we are having. So all these USRPs, the workstations we bought from the project, different project funds. So we can see the received data. What I said, the received data is delayed by some amount of time in the time domain. So how much of minutes it is showing? Some minutes. So 0 to maybe some milliseconds or nanoseconds. So that millisecond we have to identify. From there we have to start your reception. So we have designed our own synchronization for the receiving of in phase of data after ADC in the receiver USRP. So this is a PAM modulation, pulse amplitude modulation. You know the pulse amplitude modulation, right? So we will change the amplitude of the signal. So we are seeing a 4 PAM. This is a 4 PAM. So this is my received data. So after identification, this is my received data. So received constellation for 4 PAM at an SNR of 20 dB. So we have kept my transmitted signal at 20 dB level. Then this is my received SNR, received signal scenario. So then this is for PAM, only for different amplitude modulations. Now we incorporated the same concept for multi-carrier modulation scheme. So what is multi-carrier modulation scheme? OFDM, right? So we have designed simple modulation scheme, then we imported onto multi-carrier modulation scheme using IFFT and FFT block. Every block is designed on our own in the lab view. So there are some references. So still time is there? Yeah, that's So, explained all these basics. To a diode, if you give an AC current, output will be only a half wave cycle, right? This is the OFDM format, e power j 2 pi n k by capital N. This is my 50 block and the diode characteristics. So, this is about Hermitian symmetry. So, we will execute this Hermitian symmetry now. So, this Hermitian symmetry, imposition of the Hermitian symmetry, have a look at it. So, we are using n number of subcarriers from 0 to n minus 1. So, on each subcarrier, first subcarrier is made 0 and n by 2 minus 1 like that. So, 0 0 and 1 we have imported a data of first symbol, like that we have imported up to n by 2 minus 1. From 0 to n by 2 minus 1, we have carried the same data what is available in my stream, right. Then center we made as a 0. The remaining one is only complex conjugates of the previous one. That means, can you write a formula for complex conjugate computation? I have given x of k. I want to make in this format. So, what is the format? N by x of n by 2 minus 1, just have a look at it. X of n by 2 minus 1 has to be placed after the center carrier x of n by 2 with a complex value. That means, we have to make it as x conjugate of n by 2 minus 1. Can you think about some logic? So, now you see the last one x of 1, x of 1 is going to x conjugate of 1. What is x of 1 position? Can anyone tell me? The first subcarrier, 0th subcarrier, first subcarrier. So, first subcarrier is going to here, what is the subcarrier number? N minus 1 subcarrier with a complex conjugate. That means, x of n is equivalent to x conjugate of capital N minus small n. Can you write the formula and tell me the answer? X of n, suppose, or x of k, whatever value you want to keep, because we are talking in frequency domain. So, it is x of k to be placed in this manner, like center is 0 and here all are complex conjugates, here is the original data, right. So, that means, suppose this data is x k x of n by 2 minus 1, then this position has to goes to x conjugate of n by 2 minus 1, like this it has to go. So, we have to define your Hermitian symmetry format. What is that Hermitian symmetry format? X of k is equivalent to x conjugate of n minus k is sufficient. X of k is equivalent to k. What is your k? You keep the k. Suppose at the last point I want to keep. What is the last point? Is n minus 1. Suppose my kth value is n minus 1. My k is running at n minus 1. That means, I am computing x of k minus 1 is equivalent to how I am computing x conjugate of n minus what is my k? N. So, n minus k, that means plus 1 minus n plus 1. So, what is the value? This is x conjugate of 1. Is it happening or not? Right? So, the first position is now mapped to complex conjugate, mapped to last position. This is called Hermitian symmetry. So, x of k is equivalent to x conjugate of n minus k. Simple technique. So, just have a look at it, how it is manipulated. It's happening, right? So, your x of 1 become x conjugate of 1 and it is placed at last position, because x conjugate of capital N minus n plus 1. So, it has become x of 1 data. So like this, half the subcarriers we are filled with original data, remaining half only complex conjugates of this data. So now this kind of a data, if you are giving to IFFT modulator, what is the output? So just have a look at 0 position and n by 2 position we are making 0, right, and x of n minus k we are using x conjugate of k, or x of k equal to x conjugate of n minus k, both are Hermitian symmetry. Now this is the placement of my signal, 0, center 0, n by 2 minus 1 actual data and another n by 2 minus 1 complex conjugates. Now we keep this data onto your signal format. So I am writing the original IFFT value, that means x of n is 1 by n, I forgot to keep 1 by n. So k equal to 0 to n minus 1 x of k e power j 2 pi n k by n. So for each x of k, just we have opened into 4 values. Why 4? Because beginning is 0 and the center is 0, I just removed that center, and remaining values k is running from 1 to n by 2 minus 1, your actual x of k, right, and again the remaining values n by 2 2 plus 1 n by 1, they are complex conjugates. If you substitute those values, only this format is remaining. So this is my signal, you can see x of k e power j n by 2 minus 1 and n by 2 plus 1 to n minus 1, this is the same signal, right. So now impose that complex conjugate. So n minus k signal we are imposing, so we have used a k dash. So now if you arrange them into this format, x of k, x conjugate of k, they come down to only n by 2 format, k equal to 1 to n by 2 minus 1, right. So now after you solve this signal, just have a look at it. X of k e power j 2 pi n k by n, right. So e power j means cos plus j sin multiplied by x of k plus x conjugate of k, multiplied with minus sign, minus j sin theta. So plus j sin and minus j sin cancelled out. What is remaining? Only cos is remaining. So finally my signal has become a real signal. Cos and sin j is eliminated using this Hermitian symmetry. You can give this topic as a project idea to your students. Okay. So really it helped us a lot in publishing very good number of papers. In the beginning of visible light communication came into existence. Not existence, the proposal came into the real world. So we just grabbed this idea in 2015. I attended one of the workshop, WCNC workshop. So many of the IITs, foreign others, that was happened in Qatar, I think, yes, Qatar. So I attended for that conference. Till now I have visited 19 different countries. So America, USA I visited 3 times and UK I visited 4 times. If you eliminate that, my travel, I visited 17 different countries till now. So till 8 more years of service is there, I want to visit rest of the, so once I visited, I don't want to visit. I plan for my other ideas, so to visit the other countries. So I make collaboration wherever I go. So I attended one of the workshop which was given by Harald Haas, who is the inventor of proposal given by Harald Haas. So I attended his presentation. I am very fortunate enough. I attended his presentation. Soon after I came, I imposed this idea to my students, my PhD scholars. So quickly, Sushila is one of my favorite students. So my beginning of my career, all PhD scholars, their name starts with only S. If he or she is S, I wanted to take them. So Santosh, Sai Krishna, Sushila, Shiva, everyone is Shiva only. So I used to take them. But so initially I gave this work little mathematics. So you don't need much mathematics because we use very heavy mathematics in wireless communication. She came from a small college. She studied in private engineering college. She has a GATE score. Her MTech is from Gayatri Vidya Parishad Visakhapatnam. Even then, she has a very good communication skill. Other faculty members thought why madam is suggesting her name, but I suggested we have to take her, and also I want to take her. So, if I want to take, so other faculty members also will run in the race. Madam is thinking means taking a student means there is something is there we want to grab. So, very fortunately I got that student, and soon I have given, you just derive the simple equations. This is the Hermitian symmetry. So, within 2 years she published 4 SCA journals, apart from completing her coursework. So, they has to complete 4 different courses, each course of 3 credits, 12 credits they have to complete. Completing her coursework, and she wrote 4 different papers, because that is the beginning of the research area. So, we grabbed it. So, we have published several papers on visible light communication. We have developed a test bed, we have designed many, this simple equation has given us 1 paper. Derivation of this equation has given us a single paper. Can you imagine how easy it is, right? Now we are feeling it is very easy, because we have derived and shown. So, initial proposal, you might have worked hard behind the thoughts. So, now we convert it into a real time. Then, so there are, now you can take this screenshot of this picture. You can give these ideas to your students, are already available in my paper, already derived, but at least see the paper and derive. Look at the paper and derive yourself. That you can give it as a one single project, as a final year project. So, discrete Hartley transform is also real transform, discrete cosine transform, discrete sine transform. So, I have explained Hermitian symmetry. So, and IFFT combination will give you a real output, right. So, without using Hermitian symmetry, if you use these transforms instead of IFFT, if you use DHT, if you use DCT, if you use DST, discrete sine transform, we will obtain a real output. Okay? You can give these ideas to your students. And Hadamard coded modulation, wavelet packet division multiplexing. So, here we have used discrete Hartley transform, IDHT. There is no Hermitian symmetry, can you see it? We have not considered Hermitian symmetry. Instead of IFFT block, we placed discrete Hartley transform, right. So, earlier example was with Hermitian symmetry followed by IFFT. Can you look at Hermitian symmetry followed by IFFT? Now, there is no Hermitian symmetry. Directly we worked with Hartley transform, IDFT and DHT, IDHT and DHT. Okay. So, same way we derived the equations, we got one more paper. So, you see, then discrete cosine transform is also used, we derived the equations. The finally, after making this become a real cos signal, and so like that many other techniques we have used as a modulation technique to place in force your visible light communication. Then also we estimated the channel employing different transforms for VLC. Using Hermitian symmetry, the channel estimation is done. Okay, I am not going to too much math, so because this entire presentation deals with only simple mathematics. Then we have used a unipolar and how the signal is working. So, this is the channel estimation technique we have used. And this one is DCT based spreading for PAPR reduction in OFDM techniques. So, I am not going too deep into this mathematics. So, this is the basic idea I have given. Now, can I spare 10 minutes on research for the students' perspective? Okay. So, nowadays, how many of you are using ChatGPT? I have a login ID, but I will log in later. Okay. How many of you are using ChatGPT? Most of them are, we are habituated to use it, right? So, and we forgot to keep our fundamentals in our mind. But I like ChatGPT too much. So, what I do, suppose I want to prepare a script first of all. Then I prepare a script on my own language, because my education from till 10th standard is Telugu medium only. 11th and 12th is English medium. You know the struggle we have to make from Telugu to English conversion. That is our transition period. After transition period, anyway we go into engineering. It is full. We are got habituated to learn English language, but the speaking capability is not that sufficient. But later on, with the teaching experience, okay, some vocabulary is also built up. Now ChatGPT is helping us in writing a very good script, right? So first, what you are thinking on your own way. First, write your own thought first of all. First, you write your own thought. Don't ask ChatGPT to write my answer. It will not write. It will not write. So my son is a machine learning engineer. He did his BTech from IIT Madras. He worked in machine learning. His role is the same role, the ChatGPT role. So he has to design a model based upon my thinking. It has to generate the output. So how much thought process they might be handling, right? So always he is under stress. If I ask any question, don't ask me now. I am writing a code. Okay. So now I imagined how much stress they are keeping to build this kind of a model. Anyway, they are paid very high pay package levels they are receiving. That's a good thing. But how much stress they are going to keep into the subject to keep, because my thinking has to be translated into a good model. That is important, right? So now I will write a small story and ask the ChatGPT, please correct the sentences. Okay. So then you write your own story. What you will write? You tell me. What you want to ask ChatGPT to explain the thing? Shall I ask Hermitian symmetry? Please prepare concept building of please prepare a concept building of Hermitian symmetry procedure to explain to, I am writing many blunders, to explain to a BTech third year ECE student. Okay. I am posting. This English is not correct. Whatever thoughts I have, just I explained. So what is given? Below is a concept building explanation of the Hermitian symmetry procedure tailored for a BTech third year ECE student, starting from institution and building up to practical use. How does the ChatGPT knows about Hermitian symmetry? If it is the same concept, if we type in the Google, it will give hundreds of lectures where we will land up into a trash, which one has to be taken, which one has to be not to be taken. We spend lot of our time, right? But ChatGPT has given a nice, wonderful structure. What is Hermitian symmetry? Concept building first of all. So this is says Hermitian symmetry appears when you work with signals in the frequency domain, especially when using the discrete Fourier transform. We have used a DFT, we have used FFT, right? Why do we need Hermitian symmetry? Most real world signals in ECE are real valued in the time domain. So further it will give you further answers also. So what is Hermitian symmetry? The concept is given: x of k is x conjugate of n minus k. X of k is the DFT, x conjugate mixed complex conjugate, n is the length of the DFT. the spectrum is mirrored around the center. So, Nyquist frequency, the mirror copy is complex conjugated. Do you need a teacher to explain? I do not think we need a, really have patient enough. You want to learn anything, you can use ChatGPT. So, nowadays what students are doing? Simply taking from the ChatGPT and pasting and showing to the teacher, this is my output. Now, we are in a problem what to do with these results. Whether have they executed DFT, IFT? No, they are not executed. Just they are taking the copy paste of ChatGPT output and showing this is my output. Unless really work into the problem, you do not identify the waveforms which were generated from ChatGPT, which were generated on your own, right. So, before explaining anything, you have to practice yourself, but you can use this tool. I am not denying that do not use this tool, use this tool. So, there are many tools like that. There is another tool, human AI, humanize AI. You give a text from the ChatGPT and ask the humanize AI, write similar thinking of human. It will convert into a lower language. Okay, that means some work is done. But still we identify as a professional of EC, we identify is it humanize AI or is it a ChatGPT AI, no problem. So, we are working. There is another tool, Quillbot. How many of you know? Are you using Quillbot? Initially my son designed this Quillbot. He was into Quillbot, then he is moving some, yes. So, we can write, we have to sign up anyway. We can give a grammar check or a paraphraser. So, you can paste your text over here, ask to correct the sentences. If you feel that I am weak in my English, write in your own language first. Do not take any text from ChatGPT or humanize AI or Quillbot. Quillbot anyway is only for correction, right. So, first write into your own language, then paste this one into any of this text, then take the output and see the difference, compare. So, what should I write? I have to write in this way, but I have written in this way. So, make a correction. So, by that way you can improve your language to a universe. You can explode. You can explode your knowledge. There is no limit for learning in this universe. There are many tools. So, I have shown you the text studio earlier in my PPT. So, for writing the equations, we use a LaTeX editor. We do not use the Microsoft Word, because in the LaTeX it gives the numbering, figuring, alignment, everything on its own. You need not maintain all the alignments what you are doing in Word. Okay, that is about the tools available. So, like that so many tools are available, and you can use IO draw in Google. So, where you can draw your diagrams. IO draw, but it must be Google. It is a Google app. Draw.io, draw.io, is it a Google? Yes, it is a Google I/O. You can start now. So, you can draw your diagrams. Okay. So, like simple circuit diagrams you want to draw with a diode. We have drawn the pictures, right? So, all the pictures were drawn from Google I/O draw only. So, we can use these tools for your PPT presentations, and we use always math editor for later for equation editing. iMath EQ. I always use this iMath. So where I can edit my equations. Because especially for signals and systems question paper, we have to write so many equations, so many diagrams. We have to use these tools. Okay? IO math for submission of your, here internet is very slow. So the, yes, right? So we will write an IFFT equation. In this one, I will write an IFFT equation. Because it is an iPad not supported by the text, otherwise I would have shown you in that one. This has not having full compatibility because it is an iPad. So I cannot show you how to type the equation over here, but you can see you can use the math, you can use the summations, you can use for so this is, you see, right? I can use n equal to 0 to n equal to -1. So here typing editor is not coming, otherwise I can show that one. So you can use this one for equation editing. So there are so many tools available, and Visual Studio is one of the tool where we can draw your diagrams, we can paste these equations onto the diagrams, right? So many things are available. So now coming to your placements, finally at the end of the day after receiving your degree, everyone is, why we are doing? Only for our food, but right? For our food only, for our survival. So what do you need? So we have to be placed in a good company, good package and easy going life. That is the ultimate goal. So nowadays you know that software, because of the recession, the companies are laying off the members, and there are no new positions are vacant, only all older people are coming again back to the new positions. So Amazon laid off and Google laid off, every company, LinkedIn, many companies. Even my son also lost his job, and again, but they have their own techniques. So he lost his job and again he joined to, my daughter-in-law, she was into Microsoft, she was also laid off. You can see how much struggle, how much pressure they would have taken. But so it is a never ending process, a lifelong learning process for us. We have taken a birth in this earth means we have to learn from our experiences. Okay? So what is our final goal? You want to stop at BTech, you want to stop after MTech, you want to stop after PhD. 3 sets. So do you want to go for software? Do you want to go for hardware? You have to decide yourself. So in which area you are perfect, right? Based on that you have to sit for your companies. But I don't know whether hardware companies are coming to your campus or not. So even if you are sitting for software companies also, you should not lose your concentration on fundamentals. Some or other places you will use your optimization techniques into software, all your learning algorithms into software. So we have used a LabVIEW license. So what you have done? We have written a code. For what that I have written a code? Because I have a knowledge of C, I have a knowledge of C++, I have a knowledge of Java, right? Because of this knowledge only, I could code my communication into the software. It is a never ending process. So I don't need hardware, I don't need I need only software, I learn only C. No, it's not the case. You learn any subject that will be helpful in some or other way in your lifetime. So next, there are many opportunities for the students. Suppose you are having 7.5 CGPA in your BTech, and if you are a GATE qualified, you have to appear for your GATE, you must obtain some score, minimum score. Then you are eligible to opt for PhD in NITs. But IITs, they are considering, also they are considering PhD program. So there will directly join into PhD program. So these 2 years of MTech and PhD together will give a degree. And I am sure if you are more than 7.5 CGPA and a minimum level of score of GATE, so you are eligible to admit into NITs. Okay? So once you join into NITs for a PhD program, there is no problem for you can, because of this NEP rule, new regulations, you can break your journey in between also. That means you can end up with your MTech program and you can go away. So there is an opportunity, lot of opportunities are there, the campus placement. Main is campus placement. Many companies are coming to NITs and IITs. You can take one job and you can go away, or you can continue your PhD program. And there are certain PhD programs where we have a collaboration with foreign universities. So 2 years we work with us, 1 year we will be working with foreign university. And 1 year, if extendable, minimum 2 years you can work with foreign university. So you have a good exposure. You need not spend 50 lakhs of rupee from your parents' money to go to abroad to continue your MS degrees. Nowadays anyway, MS is also, many of the are because of the Trump effect, nobody is going to choose MS to go for MS higher studies. So there are a lot of opportunities in Indian community only, Indian NITs and IIT system. And all faculty are well qualified because we obtained our degrees from IITs and ISCs. So definitely you will gain lot of knowledge. So for your lifelong survival. That is my sincere advice. If you are not obtained any placement from your campus, don't stop your journey. You go to the next level. What is the next level? Go for higher studies. So you take, but you have to be qualified in GATE. So from the second year onwards, you have to train your students. Please write GATE examination. You give GATE coaching classes in the evening time. Okay? Or maybe they can take up any online classes. So must and should they have to write their GATE. So then there are a lot of avenues or possibility are there. You don't believe, during my PhD program, I also studied from the government engineering college only. College of Engineering, Andhra University. BTech, College of Engineering, Andhra University, MTech. It's a normal government college. Then I moved to IIT. So after 2 years of my work experience at IIT, after continuing my PhD program and TA program, I visited 4 countries. IIT Delhi has given me opportunity to support my travel. Can you imagine? Is it possible? I enjoyed a lot of government money to travel across the entire world. That is one of the best profession in your system, where an any IIT employee, if you ask how many countries you have visited, if I ask my son, he will say 3. I will say 20. Who is powerful? I am powerful, because I have seen with eyes what is there, what kind of a people or what kind of a work they are continuing, right? What kind of a culture they are having, what are the facilities they are having, where we are lacking. So you can explore lot of avenues if you have the vision to continue to sustain in this universe. Nobody is, but you have to spare some money for your internet. At least monthly package, $299 or $399 package if you maintain in your mobile, you can keep a hotspot, so you can explore the entire universe. That is my sincere advice. Okay? So what you learn from the fundamentals. That is the only motivation. It will bring you to stand in this universe like a perfect woman or a perfect man. So thank you so much. Is still time is there? Is over. Over. Right.
On behalf of all our participants, now I would like to thank our speaker, Dr.V Mani ma'am. Ma'am, first of all, again, we have enjoyed the scenario of sitting in a classroom and writing on the books with a pen. Actually, my students every time face the same issue. Now I am also facing what they are going to think about me. Anyhow, ma'am, we have learned, we have enjoyed a lot, even mathematically, every step how we are going to get, how we are going to simplify, and we have learned something new like USRP and all. Thank you, ma'am. Thank you for enlightening us with your expertise. If possible, we are expecting some more sessions from you in the future. Thank you, ma'am. Now I request our HOD sir to honor our speaker.
Story of my tab and story of my pen. So during COVID, for me, because I don't maintain any PPT, till after attaining maybe past experience, previous experience together, maybe around more than 26 to 30 years of experience. But I never used any PPT. But during COVID time, there is no other idea. How to use PPT. Then just before COVID time, Apple